Hello, everyone. My name is Haley Cassidy, Americhem's Global Digital Marketing Manager. I'd like to thank you all for joining today's webinar, Custom Engineered Compounds that are both durable and dazzling, which is where we will explain how we custom design high-performance engineered compounds that not only can endure a variety of extreme weather conditions, but also look attractive in a multitude of applications such as recreational vehicles, industrial products, and much more. All attendees are muted, so please send in your questions through the questions tab, and we will address them at the end of the presentation during our Q&A segment. Today, we will start with a brief introduction of our panelists and who Americhem is, followed by how our ColorFast HGA compounds can be cost-effective replacement to paint, and how our structural compounds such as InStruc and InLube can increase performance as a replacement to metal. Then a material comparison by properties per application, and lastly, we'll take your questions. Today, I am joined by Gary Lane, Senior Account Manager for Americhem Engineered Compounds, or AEC, and Jim Howard, Senior Account Manager for AEC. I will now turn it over to our panelists for them to give brief bios of themselves, followed by the rest of the presentation.
Thanks, Haley. My name is Jim Howard. I'm an account manager with Americhem, the Engineered Compounds Group. I've been with the company for over 7 years now, and I've been in the plastics industry for over 30 years, starting my career in the injection molding side of the business, and then moving over to resin and compounded product sales for the last 25 years or so. Gary?
Yeah, hello everyone, and thank you for attending today's presentation. I'm Gary Lane. I've been with Americhem coming up on 2 years now. I have over 40 years in the plastics industry and 30 years specifically in thermoplastic compounding industry. Held a variety of positions from technical sales to product management, applications development, and market manager. Educational background is a bachelor's in plastics engineering from what's now UMass Lowell. And today I hope to make you aware of some new options and a progression of materials in the highly aesthetic and durable outdoor weatherable compounds area. Before we do that, a little bit about Americhem. We are a privately held company with over 80 years of growth and innovation with 12 locations across NAFTA, Europe, and Asia. We have 900 employees globally with worldwide sales and technical support, and we're recognized as a global technology leader in the plastics industry. A little bit about our brands. ColorRx is our approved biocompatible resin and color technology for the medical industry with the precise properties you need for your body contact applications. InStruc, which Jim will talk about, is our structurally reinforced compounds using reinforcements and fillers. InStruc is electrically active compounds and alloys, including anti-static, static, dissipative, and conductive technologies. InLube, which Jim will also talk about, is the internally lubricated compounds and alloys that improve wear performance and reduce friction and noise with the addition of fillers and alloy technology. ColorFast, and I'll be talking about ColorFast HGA. ColorFast are our custom color compounds producing opaque, translucent, and/or transparent colors. The Serlin Reflection series are alloys based on ionomer technology, creating a combination of durability and aesthetics and outdoor applications. I'll also be focusing on those. And then we have thermally conductive compounds, that's InTherm, and high specific gravity compounds, HighGrav. Now I'll turn it over to Jim to give a bit of a primer on what you can expect from our reinforced InStruc compounds as well as our filled InLube compounds. Jim?
Thanks, Gary. I'm going to start my portion of the presentation with a discussion on our InStruc compounds. Our InStruc compounds are structurally reinforced compounds for improved strength and stiffness. Certainly there are a lot of properties and materials that you need to look at when deciding on a material for your application. Today I'm going to focus on the structurally reinforced compounds and what that does to the strength and the stiffness of the material. Today I'm going to talk about our two most common reinforcements, glass fiber and carbon fiber. First, I'd like to give a little background on what our unfilled polymers look like in terms of properties. Today, I'm going to be focusing on two properties of materials, the tensile strength and the flexural modulus. The tensile strength is pretty straightforward in terms of being the strength of a material to withstand a certain load. The flexural modulus is another way of saying a stiffness of the material or its resistance to bending. All of these, both of these properties report in pounds per square inch, so all the values that you see will be in PSI, pounds per square inch. Typically with tensile strength, most of the materials that we're working with, unfilled, unreinforced polymers, are in the range of 3,000 to 10,000 PSI. So as you look at our list of materials, many of them that you're familiar with, polypropylene, ABS, etc., you'll see the tensile strength of these materials in unreinforced. On the right-hand side is the stiffness of the material, and most of the materials that we work with, unreinforced, have a flexural modulus between 200,000 and 400,000 PSI. You'll note the one exception to these properties is the PEI material, which clearly has higher strength and stiffness in an unreinforced polymer. The first reinforcement I'm going to talk about is our glass fiber products. The advantages of glass fiber in a compound are twofold. First, it provides significant increase in strength and stiffness when compared to an unreinforced polymer. You will see in the subsequent slides that the amount of increase does depend on the polymer. The second advantage of glass fiber is certainly the economics. It is low cost, and that is why it's so widely used. The cost of glass fiber is almost always less than the cost of a polymer. The disadvantages of glass fiber include the fact that it increases the density of the material. And if your application is such that higher weight is not desirable, this could be a disadvantage. Glass fiber also promotes differential shrinkage during the molding process, which can lead to part warpage. And lastly, glass fibers typically are not a good choice for any applications where there's a wear surface. In this slide, I use 30% glass fiber as a baseline to compare properties. Keep in mind, we can customize the formulation to include various levels of glass fiber, typically ranging from 10% or so on the low side to up to 50% or so on the high side. But 30% is a common number, so I use that here for comparison purposes. You will see that the materials on the left, amorphous, and on the right, semicrystalline, you'll see the tensile strength, which previously was in the 5 to 10,000 PSI range in an unreinforced grade, have now greatly increased, with materials reaching over 25,000 PSI for strength on the amorphous side and 30,000 on the semicrystalline side. You'll also note that some materials show an increase much higher than others. Material like ABS and polycarbonate, the tensile strength is about 3x of an unfilled version. Next, I'm going to talk about the stiffness of a material. This is measured in what is called flexural modulus. So in this slide, you'll see the 30% glass fiber reinforced materials, amorphous and semicrystalline, that we've raised the stiffness of a material from the 200 to 400,000 PSI range now to over 1 million on amorphous materials and over 1.5 million on semicrystalline materials. Again, some materials see much greater increase in terms of the properties as opposed to others. It just depends on the polymer. Next slide. So the second reinforcement that I'm going to talk about is carbon fiber. The advantages of carbon fiber are, first, that it offers the highest strength to weight ratio of all our reinforcements. Secondly, it allows us to achieve the very highest modulus of any of the compounds that we produce. And thirdly, it does improve wear resistance versus steel and other filled polymers in certain dynamic systems. The disadvantages of carbon fiber, first and foremost, is the cost. It is much less economic than a glass fiber. Typically, carbon fibers are many times higher in cost than glass. Secondly, a disadvantage of the carbon fiber is that it also creates differential shrinkage in the part during molding, similar to glass fiber. In this example, I've used 30% carbon fiber reinforcement to show the impact of properties on the various polymers. You now see tensile strength values above 30,000 for amorphous materials and over 40,000 for semi-crystalline materials. This amount of increase is 2x, 3x, or even in some cases 4x what the unfilled polymer is. A material like nylon 6,6, which is very common in glass and carbon fiber reinforced grades, sees roughly a 4x improvement in tensile strength when 30% carbon fiber is added. On the flexural modulus side, again, you see some significant increases in the stiffness of the material when the 30% carbon fiber is included. On the amorphous material side, modulus numbers now reach over 2.5 million psi, and the flexural modulus of semi-crystalline materials can reach over 3 million psi. In this case, such as a nylon 6,6, the stiffness of the material with 30% carbon fiber is close to 10 times the stiffness of unreinforced polymer, thus showing the advantage of the reinforcement. Some of the applications for InStruc materials really are any place you need structural components where higher strength and stiffness is needed when compared to unreinforced polymers. This would include housings, covers, chassis, handles, and support brackets. These applications occur in all industries: consumer, industrial, medical, and automotive. They include high temp applications. In many cases, these can be custom colored products, and we can custom formulate the products to match your application needs. The applications as shown in the pictures would include drapery and window hardware, covers for electronic components, filter housings and related components for industrial beverage and filter components, and lastly, industrial pump components. Now I'm going to talk a little bit about our InLube compounds. And our InLube compounds are our lubricated compounds that provide performance improvement in areas of wear and reduction with noise and coefficient of friction. The common additives that we use in our InLube product line to achieve this performance include PTFE, silicone, molybdenum disulfide, graphite powder, aramid fiber, aramid powder, and the use of various polymers in an alloy technology to create improved wear, reduced noise and friction. In the chart on the right, you will see two materials were used for our InLube studies, polycarbonate and nylon 6,6. We use various reinforcements and fillers, including silicone, PTFE, glass fiber, and carbon fiber, in various combinations to improve the wear, reduce the wear factor, to reduce the static coefficient of friction, and to reduce the dynamic coefficient of friction when wearing against steel. Wear applications are difficult to formulate because each are unique, but this chart shows you various combinations of fillers and reinforcements that allow you to reduce wear and reduce coefficient of friction. Applications for our InLube compounds include gears, pulleys, bushings, bearings, any place where there's relative motion and reduced wear is needed. These applications occur in all industries: consumer, industrial, medical, and automotive. They can include high temperature applications. In almost all cases, these formulations are custom colorable. And again, we will custom formulate the product to match your application needs. I'm going to finish my section of the presentation this morning with a case study example of a medical product, a tissue biopsy system in which many of our materials were used. These materials showed our ability to provide specific custom colors to match the customer's needs, as well as custom InLube formulations to provide low coefficient of friction and low noise. These materials included a high flow polycarbonate, custom colored to the various customers' target colors, our InLube PC and PBT materials using PTFE and silicone for reduced coefficient friction and low noise, and all of these materials were produced in very tight tolerance moldings. These application reflects our examples of our ColorFast PC line, which Gary will talk more about, in which we provide our products in custom colors, as well as our InLube product line, which again was in polycarbonate and PBT. Gary, I'll now turn this over to you to talk about the Surlyn Reflection Series.
Yeah, thanks, Jim. As I mentioned earlier, I want to switch gears now and talk about our highly aesthetic and durable outdoor weatherable compounds, and that does begin with the Surlyn Reflection Series. But today I'll put a little bit more focus on our latest in this progression of materials, the ColorFast HGA series, and HGA referring to high gloss alloys. So to give you an overview of options in this class of compounds, the Surlyn Reflection Series remains the leading product offering here. The ColorFast HGA series is our latest development in these types of compounds, and these are proprietary alloys developed by Americhem. Our HGA 1500, which is an enhanced impact modified nylon 6, offers many of the same features as our Surlyn Reflection series, with slight trade-offs in impact performance in order to achieve improved economics and flow characteristics. Our ColorFast engineering compounds include our proprietary UV stabilization technology to again provide outdoor durability and still offer excellent aesthetics. Okay, so the Surlyn Reflection series has been featured in prior presentations like this. It's a patented PA6 ionomer alloy featuring DuPont Dow's Surlyn ionomer, and it remains the premium offering, as I said, in this space, excelling beyond the performance of conventional options in all the critical performance criteria. In this slide, we take a look at some of our offerings in this segment versus some conventional resins that are used. And on a scale of 1 to 5, with 5 being the best, we rate them. Properties of interest on the left, and primary, of course, is appearance. The parts need to look good, especially in industries like recreational vehicles, lawn and garden, farm equipment. They need to look good. The color is often the brand distinction. High gloss and paint replacement type quality finish are required. So weatherability and long-term appearance for both color and gloss retention are important. Scratch and mar resistance, toughness, particularly low temperature impact performance, and then chemical resistance. Often these products have contact with engine fluids and cleaners. And then heat resistance, often high sun load applications in Florida and Arizona, in the case of a golf cart, for example. So looking across the product range, the Surlyn Reflection series is the premium product for the combination of appearance, weatherability, scratch, and low temperature impact performance. But really falling closely behind that is our ColorFast HGA 1500. This is a proprietary PA6 enhanced impact alloy, as I mentioned. And you do see slight trade-offs in weatherability and low temperature impact, but the processability of the resin is better. We also have a ColorFast HGA 5500 product, which is based on high density polyethylene, and this offers superior gloss and enhanced scratch and weathering versus conventional polyethylene or polypropylene type materials. We have a ColorFast ASA product here with a proprietary UV stabilization technology, enhancing the performance, and it offers a good all-around performance, processability, and economics for these types of applications. The ColorFast ACR is a UV stabilized impact modified acrylic, providing excellent outdoor performance for injection molding or extrusion applications. It can be formulated in a high gloss or matte finish and high opacity and thin thicknesses for capstock type applications. Okay, move to an application story. So this first application story, I want to highlight the hood and forward cowling on this snowmobile. The customer was experiencing breakage at low temperature and looking to reduce costs by eliminating the need to paint. Surlyn Reflections was the choice here for the ultimate in low temperature impact performance. Demonstrated ductile impact at -30 degrees. It provided resistance to the fuels in the gas tank area and provided a high gloss Class A finish directly from an A1 polish mold. It met the OEM test requirements across their full color range and resulted in a significant cost savings in comparison with painted parts. Now, the next case is the full front and rear body panels on an industry-leading golf cart. So this customer had poor prior experience with attempts at molded in color. Appearance, scratch, toughness, weathering were all insufficient. They were still looking for an option with an alternative to painted parts. With the Surlyn Reflection Series here, we successfully color matched their full product range with a high gloss finish, high distinction of image. We were able to meet their long-term weathering requirements, such as those sun loads I mentioned on golf courses in places like Florida and Arizona, ductile impact performance over the vehicle's operating temperature range, and it also survived impact resistance to a 2-iron, as well as resistance to cleaners and chemicals. The ColorFast HGA high gloss compounds. These resins are proprietary thermoplastic alloys, as I mentioned. It's the next generation in this evolution of outdoor weatherable materials available from American engineered compounds. We alloy with nylon, high density polyethylene, and other polymers. In a minute, I'll highlight some property differences rather than just a ranking. And as I already mentioned, this series provides characteristics of the Surlyn Reflection Series and the trade-offs I mentioned before, low temperature impact, but we do see some improved economics and better flow, better processability. Next slide, the property comparison. So this shows a comparison of key properties of the Surlyn Reflection Series in the first column versus the new generation ColorFast HGA, and then a mineral filled version of that product contrasted against some other industry notable compounds slated for similar type applications. You'll see a TPO there, and then an ASA, which was known as the weatherable polymer. Some of you might be more familiar with trade name. My trade name for ASA type compound would be Geloy. And then a PBT, you might be more familiar with the trade name of Xenoid type materials. So you can see we talked about trade-offs of the HGA series. Here you can see the sacrifice and impact when coming down from the Surlyn Reflection Series. So you've got, you go from 28 down to 16. And then you do see the enhanced flow I talked about. So the MFR going from 7 up to 12. So we're also able to modify these grades with minerals. In the third column, you'll see the ColorFast HGA 1500 MN10, which is a 10% mineral to achieve a higher level of stiffness. Or as will be shown in a case study here in a minute, we can modify the shrinkage of the material. Next slide. Okay, so here's another application story of a supplier to the trucking industry, and they were experiencing breakage in their existing refrigeration unit panel doors, and we're looking for a running solution to a current program. Americhem positioned our HGA 1500 MN10, and it demonstrated high impact strength, low temperature ductile performance, and eliminated the breakage they were experiencing entirely. It was colored matched to the existing model adjacent parts, and the mineral version was tailored to adjust the shrinkage to match the existing tooling shrinkage, which was designed for the incumbent amorphous material. It displayed resistance to scratch and chemicals and conformed to the OEM specified xenon exposure protocol. And the final case here is a recreational vehicle. This is an ATV or a side-by-side. The OEM was looking to replace painted parts to reduce cost. We proposed our ColorFast HGA 1500. That again is the nylon 6 alloy, high gloss, high distinction of image, high flow. We color matched multiple brand identifying colors. We demonstrated durable ductile performance in demanding off-road test criteria. It demonstrated excellent chemical resistance and scratch resistance. And the high flow of this HGA grade was able to fill long flow areas throughout the part. This was a nice success story. And then the next one. Okay. So we'll talk about economics a little bit, but first, this is a graphic representation of some of the key performance criteria typically noted for this general class of materials. This again highlights the combination of the properties of the flagship Surlyn Reflection Series as the ultimate in terms of overall appearance, weatherability, toughness, and also illustrates the new HGA series is running right behind with a little bit better economics. Just to touch a bit more on economics, eliminating paint can improve yields, reduce emissions, reduce work in process waiting for paint. And with these molded in color options from Americhem, You have the versatility of producing high gloss or low gloss, paintable or even film decorated parts, all from the same mold. So that's about it, Haley. So I hope our attendees will consider working with Americhem Engineered Compounds for your custom compounding needs, whether it be reinforced or filled materials that Jim talked about, or the highly aesthetic, outdoor, durable, and dazzling compounds. So please get in touch with us.
Thanks, Gary and Jim. That was a great presentation. I want to briefly mention here that our next webinar does take place on October 14th, and it's the final part of our three-part fiber series titled 3 Must-Have Functional Additives in Fibers, with October being part 3 and focusing on textiles. You can sign up to be notified of all Americhem news on our website by going to the contact page and signing up for our monthly newsletter. We will now move on to the Q&A portion of our webinar. I'll be reading off the questions that have been submitted and pass them on to our panelists for answering. So our first question is, can you provide compounds that are both structural and lubricated in one?
Yeah, I'll take that one. The answer is yes, we can. It is very common to see materials such as polycarbonate with both glass fiber and some type of lubricant like a PTFE and silicone. So yes, we can do that.
Okay, our next question, is it difficult to custom color glass fiber reinforced materials?
It can be, depending on the polymer. Some are relatively easy, like a glass-filled ABS can be very easily colored. So the short answer is yes, but it depends on the polymer.
Okay, our next one. You mentioned significant cost savings on the snowmobile application. Can you say what the actual cost savings were?
Yeah, I'll take that one. Yeah, so that was significant. $80 per part was the cost savings on that part.
Okay. The next one here, does the Surlyn Reflection Series need to be dried before processing?
Yes, that we do recommend drying. Recommend 6 to 8 hours at 140 to 150 F, somewhere in that range.
Okay, next question. Can you customize the ColorFast HGA series and can it be reinforced?
Yeah, we can customize. So let us work with you from the beginning to review all the critical quality requirements that you have, and get the correct series, get you lined up with the correct series to help get you started. Yeah, we do have reinforced grades, but you know, there is some sacrifice in appearance when you reinforce these materials.
Okay, so we are just about at our 30-minute time limit here. So any other questions that come in, we can follow up with and get in touch with you after the webinar. I'd also like to briefly mention here how you can ask us further questions after the webinar is over. You can certainly connect with any of our panelists on LinkedIn, but you can also go to the Americhem website and ask us questions through the instructions that you see on this slide. If you go to americhem.com and click the Contact Us page, then choose the contact form that states I have a general corporate inquiry, and choose the option to send that form to marketing. I'll be receiving all of those questions directly and follow up with our panelists as soon as possible. You can take a screenshot of these directions, but we'll also be sending out a follow-up email with the directions and a link to the contact page. So that wraps up the Q&A portion of our webinar, and I'd like to thank our panelists for their time today, and I'd like to thank our attendees for joining Americhem in this important discussion about custom engineered compounds. Thank you again for joining our webinar, and that concludes our presentation. Thanks, guys.
Thank you.
Yo.